All right, here we go. So we're going to start our final unit here called probability. And this is the cover of the packet. You can see the familiar Wheel of Fortune wheel right here. So probability is this studying how likely something is to happen. So in this unit, we're going to take a look at some different events, and we're going to learn how we can represent how likely it is for that event to happen in different ways. And we're going to start off by thinking about socks. So I believe this is on page 4. So we're on page 4. So at the top it says, the probability of an event is a ratio. Again, a ratio is a comparison of two things that compares the number of favorable outcomes to the number of possible outcomes. The favorable outcomes to the possible outcomes. An outcome is the possible result of an experiment. You can also think of a probability as the chance that an event will occur. And this is just a little formula here to show you how we might write a probability. So how you'd read this is the probability, where it says P, probability of an event is equal to the number of favorable outcomes, so the number of outcomes where that event will happen, to the number of possible outcomes. So we're going to take a look at a situation here, and we're going to use that situation to help think about how likely it is for that to happen using probability. So it says, let's say that one morning before school, you randomly select one of the 4 socks shown. So let's say these 4 socks are in a drawer. Their pairs are not in a drawer, so it's just these 4 socks. We have a polka dot sock, stripe, zigzag, and Cheez-It. It says, what are the possible outcomes? Well, if you're going to pull out one sock, you're either going to get polka dot, that's one outcome. You're going to get this, or the striped one, because you're picking out only one. Zigzag, or Cheez-It. So those are the 4 possible outcomes. It says, write the probability you would pick a zigzag sock as a ratio. So what this says is probability of zigzag equals, well, what are the number of favorable outcomes? How many times could you pick the zigzag sock out of these 4? Well, there's only one. So there's one zigzag sock out of how many total socks are there? How many possible outcomes? Well, we listed them here, 1, 2, 3, 4. So the probability of picking a zigzag sock is 1 in 4. We can write that probability in different ways. So it says, write the probability you would pick a zigzag sock as a percent. So I'm going to write probability of zigzag. Write that kind of small here. I'm going to do the math for this off to the side a little bit. So I'm going to kind of do it up here. So we want to write this as a percent. Well, 1 out of 4, we can't really write that as a percent because percents are out of 100. But we can get that 4 to 100 pretty easily if we multiply by 25. So we're going to multiply the top and bottom by 25. And we get 25 out of 100, which is, that's 100, 25%. So just as we can write any fraction as a percent, we can write any probability as a percent too. So the probability of a zigzag sock is 25%. Okay, it says write the probability you would pick a zigzag sock as a decimal. We're going to set that up in a similar way. Probability of zigzag. Now, to write this percent as a decimal, all we'd have to do is move the decimal point 2 times to the right. So if we have 25%, to make that a decimal, you just move it 1, 2 times to the left, and there you have it, 25 hundredths, which makes sense because 25% is 25 out of 100. 25 hundredths would be the decimal. Okay, so we can show decimal or probabilities, in 3 different ways: as ratios or fractions, percents, and decimals. Each one of these probabilities means the same thing. It's just shown in a different way. Now let's take a look at another event here, another example using this same set of socks. It says, write the probability you would not pick the Cheez-It sock. Not pick the Cheez-It sock. So that's a key word there, not pick the Cheez-It. So the probability that you do not pick the Cheez-It sock. Well, how many possible favorable outcomes would there be? Well, that means how many different chances are there to not pick the Cheez-It sock? Well, you could pick the polka dot sock or the striped sock or the zigzag sock, and that would be true. So there are 3 possible favorable outcomes. And how many total outcomes could there be? Well, there's 4 total socks. So the probability of not picking the Cheez-It one is 3 to 4. There are 3 favorable outcomes out of 4 to not pick it. All right, well, let's write this as a percent. So we'd write the probability of not Cheez-It. Whoa. Now, we looked moments ago at the probability that we would pick the zigzag sock. That was 1 out of 4, and the percent was 25%. So this time we're looking at 3 out of 4, which is, it's going to be similar to 1 out of 4 because we have the same number in the denominator. So we're trying to get to 100. We're going to multiply by 25 on the top and bottom. And we get 75 out of 100, which is 75%, which makes sense because 3/4 is kind of like 3/4, and 3/4 is worth 75 cents. So the percent that you'd not pick the Cheez-It would be 75%. Then it says, write the probability you would not pick the Cheez-It sock as a decimal. Similar to what we did in the previous example, I'm going to write probability of not Cheez-It, which should be more likely to do. So it seems like it's more likely that you would not pick the Cheez-It sock than you would. That's why the probability or the percent is so high. Okay. The decimal would be, well, you can kind of use this fraction here to help you. 75 out of 100. 100 is 75 hundredths, which would be the decimal. All right. There's 2 more events down here that we're going to think about. These are kind of unique. It says, write the probability you would pick a sock as a ratio, decimal, or percent. So the probability that you pick any sock. So if you reach in to grab one of those 4 socks, what are the chances that you're going to pick a sock? Now, if these are the only 4 things in the drawer, the favorable outcomes are you could pick this sock, this sock, this sock, or this sock. So there are 4 favorable outcomes there. And how many total outcomes are there? There's also 4. So the probability of picking a sock is 4 out of 4. You're definitely going to pick a sock. If you reach in and reach into the drawer and there's only 4 socks in there and that's it, the probability of picking out a sock would be 4 to 4. Okay, well, what about that as a decimal? Well, actually, let's think about that as a percent first. As a percent, you're definitely going to pick that out. I'll show you this, but we might not have to do this anymore, knowing that 4 out of 4 is the ratio. 4 times 25 is 100. 4 times 25 is also 100. So that means that's 100%. And in probability, that means that it's definitely going to happen. Okay. Now, as a decimal, this one's a little unique because as a decimal, we would have to move the decimal point 2 times to the left, just like we did the previous one. And when we do that, the decimal is actually just the number 1. Okay, so this particular event is certain to happen. So I'm going to write that below. This is certain. If you have 4 socks in a drawer, what's the probability of picking out a sock? Well, it's 100% probability. It's certain to happen. All right, let's take a look at another example, kind of similar, but maybe opposite. It says, write the probability you would pick a plain white sock. Well, we're going to write that out, probability of a white sock. Okay, how many white socks do we have? Just plain white socks. We have 0. Okay, what are the possible outcomes here? There's still 4 socks in there. So the possibility of picking out a white sock would be 0 out of 4. Now, as a percent, it'd be pretty clearly that's 0%. And as a decimal, that would also be 0. Now, this is the opposite of the event we just looked at. Picking out a sock was certain. Picking out a plain white sock would be called impossible. That event is impossible to happen. There is no chance that that's going to happen if these are the 4 socks in the drawer. So we're going to take a closer look at words like that, words like impossible, words like certain, and we're going to see how we can describe different events using those types of words. All right, so we're going to go on to page 5. Okay, so on page 5, we're going to take a look at some different words we can use to describe different types of events. So if we look on top, it says the probability of a chance event is a number between 0 and 1, expresses the likelihood of an event occurring. Greater numbers indicate greater likelihood. A probability near 0 indicates an unlikely event. 1 near 1 indicates a likely event. So it's more likely to happen closer that number is to 1. A probability near 5/10 indicates an equally likely event. Outcomes occur at random if each outcome is equally likely to occur. Okay, so let's kind of go through that a little bit. If we think of 0, a probability near 0, now that's writing that probability sort of like a decimal, but 0, you can think of that as a percent, which is a little maybe easier to think about, is going to be 0%. So if something has a likelihood of 0, that's like 0% chance. 1, which we saw earlier, would be 100% chance. So the closer the event is to being 100% chance, the more likely it is to happen. Now this 5/10 as a percent would be 50%. So that we call that equally likely, because there's not one outcome that's more likely than another. We have a 50% chance. So these 5 words or these 5 phrases will help us kind of describe different events that we may come across. If something is impossible, the percent is going to be 0%. As a decimal, that would be 0. And as a fraction, we might say that's 0. We'll just make the fractions out of 100 just because that's what percents are. So fraction is 0 out of whatever. It could be 0 out of 4, 0 out of 5, whatever it might be. If something is unlikely, and I'm just talking about whole percents now, I'm not getting into decimals, because you could write a percent as a decimal too. But we're going to say if something is, well, actually, we'll come back to unlikely. Equally likely. Okay, if something's equally likely to happen, its percent is going to be 50%, right down the middle. 50 times out of 100, that thing's going to happen. It's right down the middle. The decimal would be 50 hundredths or 5/10. We'll write that as 50 hundredths at this point. But if you drop that 0, it'd still be 5/10. As a fraction, it would be, well, there's a couple ways we can write that. 50 out of 100. But if we can simplify that to 1/2. Okay, so if something's equally likely to happen, 50% chance. If something is certain to happen, that would be like we're picking out a sock in that drawer of socks. It's definitely going to happen. Percent would be 100%. The decimal, as we saw before, would be 1. And the fraction would be, out of 100 would be 100 out of 100. It will happen every single time. So before we get to unlikely and likely, let's take a look at some types of events that impossible, equally likely, and certain. So let's think of an event that could be impossible. Okay, we might say like something impossible would be like a pig grows wings. Based on their current biology, that is impossible to happen, like tomorrow. Another one would be like the sun rises and the sun is green. That's an event that's impossible to happen. Okay. Something is certain. We're going to go to the other end. Something is certain. It's definitely going to happen. It's definitely going to happen. Okay. So something that's certain is this week we'll have a Friday. This week is definitely going to have a Friday. It's certain to happen. There it goes. This week we'll have a Friday. Another event that could be certain to happen is that next year is 2023. That's certain to happen. That is 100% certainty. Equally likely, there's like a classic example, a famous example of something that's equally likely. Flipping a coin and getting heads. Flipping a coin and getting heads. So that's 50% chance of happening, because when you flip that coin, you're either going to land on heads or tails. One of the two. There's only two chances there. So it's 50% chance that you're going to land on heads, 50% chance you're going to land on tails. And that's why those, for like overtime in a football game, they flip a coin because it's equally likely that it's going to land on heads or tails. So it's seen as like a fair event there. Each team has an equal likely chance of winning that coin toss. Another one is like if you roll a dice and get an even number. Half the numbers on a dice are even, half are odd. Get an even number. So that's equally likely to happen. All right, so what's sort of more difficult to think about is things that are unlikely or likely. The numbers are a little bit different. So unlikely is somewhere between 1%, so it's greater than 0, and 49%, less than 50. So somewhere in that range would be events that are unlikely to happen. Even if something is 1%, it's probably not going to happen, but it's still possible. It's just unlikely. So the decimals for those numbers, or for those percents, 1% is 1 out of 100, which is 1/100th. So 0.01. 49% would be 49/100ths. Okay, and then the fractions would be somewhere between 1/100th and 49/100th, somewhere in that range. So events that could be unlikely, but still possible, it could still possibly happen. It could be like 60 degrees Fahrenheit on Christmas. Now, that's not likely to happen, but it's not impossible. This is an event that could happen, but it's usually, 40 or below on Christmas Day. But it's possible that it could be 60 degrees. Okay. Another event that could be unlikely to happen, still possible, but quite unlikely, is that Mr. Levering wins the lottery. So that is an event that is not likely to happen just because the probability of winning the lottery is very small, but it's still possible, just not likely. All right, something that would be likely, it's kind of the opposite of unlikely. It's between 50% and 100%. So that would be kind of like saying it's between 51% and 99%. Somewhere in that range. Now, again, I'm not including decimals in those percents. Like even if it's 99.8%, that'd still be likely, not certain, but those percents would be likely. Decimal would be 51/100ths to 99/100ths. And the fractions would be 51/100ths, somewhere between 51/100ths and 99 out of 100. Now, I'm writing these fractions out of 100. They're not always out of 100. It depends on how many possible outcomes there are, but the value of the fraction would be between 51/100ths and 99/100ths. So some events that are likely to happen, not necessarily certain and not necessarily equally likely, is that, so I'm just making these personally about me, I guess. Mr. Levering goes to a park this summer. So that is more likely to happen. It's not certain, right? Me saying I'm going to the park doesn't mean I'm definitely going there, but I usually go to the park. Parks, different parks this summer to take hikes. So it's not certain that I'm going, but it's quite likely that I am. Okay. Quite likely also might be that someone on our base wears a red shirt tomorrow. Now, we can't be certain about that because there's no one on our base that wears a red shirt every single day. So if that were the case and they only own red shirts, that would be certain that event would happen. But it's likely. There's probably someone on our base that's going to wear a red shirt tomorrow. We have a good feeling about that. Okay. So these different words, impossible, unlikely, equally likely, likely, and certain, relate to different events that we could describe and also different percentages, decimals, and fractions. So we're going to be using these words and these sorts of numbers as we describe other events going forward in this unit. All right. So if you have any questions for me, please let me know. Hope this was a good intro to probability, and I hope to see you soon. Have a great day. Bye-bye.